In this problem, there is a two-part question. The first part, it says, find the y prime, and we know y prime is the same as dy over dx, and the second part, it says evaluate. Now, in this problem, by looking at this, we do have the value of the dx dt. Anytime you have a value of a dx dt, then when you get the derivative of a x, after you got your normal derivative, you have to say x prime, the same as y letter. Now, the first thing, look at here, is y times natural log of x. Is the product rule. Right here, x times e to the exponent y. That is the product rule. Then, in the side of my PowerPoint, I'm going to show you the derivative of each individual. Derivative of a y is going to be y prime. Derivative of a natural log of x, remember, natural log of x, derivative of any natural log is going to be derivative of this over carbon copy of this. Derivative of x is the x prime over x. Then, right here, derivative of x is the x prime. I'm going to indicate it on the second box. Then this way you can see I'm getting the derivative of a second term. Then, derivative of exponential function is going to be carbon copy, then times derivative of an exponent. Carbon copy e to the exponent y times derivative of a y is the y prime. Then, by having all this information, now I'm going to find the derivative of my problem. Now, derivative of the first, derivative of the y is the y prime times natural log of x, which I have it here, then plus derivative of a natural log of x, derivative of a natural log of x is the x prime over x, then times first, which is y. I underline it, then you can see this is the derivative of this. Now, my second term. Derivative of a x is going to be x prime times my second carbon copy plus derivative of a e to the exponent y is going to be e to the exponent y prime, then times my first, which is x. Derivative of a 6 constant is going to be 0. Now, again, it's a two-part question. I have to find the dy over dx, or the y prime. Then, the first thing I do, I would replace anywhere I see x prime, I'm going to replace it by their value, which is 5. I see the x prime here, I see the x prime here. Then I replace it by 5. Then, you are trying to solve for the y prime. Again, you can say y prime or you can say dy over dx. I do have a y prime here. I do have a y prime here. These two terms, I'm going to keep it in the first side, but this term and this term, I do not have a y prime. I'm going to move it to the second side. Both was the positive sign. Now both is become negative sign. Now, I'm trying to solve for the y prime. I know in this problem, eventually I divide. That means anytime I have a fraction, if I divide, then I'm going to get the complex fraction. Your choice. You can work with it as is. You will have a complex fraction. and get rid of the complex fraction, or right here, get rid of this denominator. That means my LCD for the entire problem is this x. Then I will multiply the x to the both sides of the equation, of course. Remember, I factor the y prime from the first term first, and now I'm going to get rid of this x by multiplying both sides by the x. Then, from here, I don't need to multiply this x by inside the parentheses. I can leave it outside, but this x, I have to multiply to the both sides. X times 5 over x is going to be minus 5 times y, and x times this, I'm going to write it down 5x e to exponent y. Now, I'm trying to solve for the y prime. Hold on to the y prime, whatever is next to it. I have an x here, and I do have this parenthesis. Then I will divide both sides by the x and this parenthesis. Then this way, this and this, of course, with this x is gone, then y prime is going to be equal this. This is my derivative. Again, you can say y prime, or you can say dy over dx. Now, that was my first part question. The second part, it says, evaluate. Now here, find f prime of a 1, 0. That means anywhere you see x, you replace it by 1. Anywhere you see y, you replace it by 0. From here, minus 5 times 0 is 0. E to the exponent 0 is going to be 1. 1 times 1 is 1. 1 times minus 5 is going to be minus 5. That means from the top, I have a minus 5. Right here, order of the operation inside. Natural log of a 1 is going to be 0. E to the exponent 0 is 1. 1 times 1 is 1. That means inside the parenthesis is 1. And then 1 times 1 from inside is become 1. That means it's going to be minus 5 over 1, which my answer is going to be minus 5.